Saxon Algebra 1, Lesson 15. In this lesson, we will look at three-dimensional objects and figure out their total surface area. That means the area of all the sides, which are really called faces, of whatever object we're talking about. Geometric figures that have three dimensions are called geometric solids. Geometric solids whose sides are at right angles to the bases are called right geometric solids, or just right solids. The top and bottom of a right solid are called the bases of the solid and are identical geometric figures. If the bases of a right solid are polygons, the solid is called a right prism. The surface area of a geometric solid is the total area of all the exposed surfaces of the solid. In this lesson, we will learn how to compute the surface area of some right solids. For our first example, we will consider a box. That is an example of a right prism. Find the surface area of this right rectangular prism. This is our box. It's 10 centimeters long, 5 centimeters wide, and 4 centimeters tall. In order to find the total surface area of this box, we need to find the surface area of the front, the right, the top, the bottom, the left, and the back. And that's a little hard to visualize here. Let's take the box apart. Now you can see the 6 surfaces that we have to find the surface area of. Let's put our dimensions back. The top, back, front, and bottom are each 10 centimeters wide. The top and bottom are 5 centimeters tall, and the front and back are 4 centimeters tall. The left and right are 5 centimeters wide and 4 centimeters tall. So now we can find the areas of each of these 6 faces. The area of the top is 5 centimeters times 10 centimeters. That gives us 50 square centimeters. The area of the back is 4 centimeters times 10 centimeters. That's 40 square centimeters. The front is the same as the back, so that's also 40 square centimeters. And the bottom is the same as the top, so that's also 50 square centimeters. The left and the right are the same. The left is 5 centimeters by 4 centimeters. That gives us 20 square centimeters. And the right is the same. That's also 20 square centimeters. So now that we know the areas of all 6 faces, we can add those areas up, and we get 220 square centimeters for the total area of our box. For our second example, we will find the surface area of a right triangular prism. It's actually turned on its side because what's labeled as the front here and the back, which you can't see, would be called the bases. And we mentioned before that the bases are usually considered the top and bottom, because the bases have to be what's called congruent geometric figures, congruent polygons. They're the same shape, same size and shape. But we can visualize the prism a little bit better when it's turned on its side like this. Well, just to get an idea of what the prism looks like, we'll rotate it around a little bit. It actually has 5 faces here. We've got to pull those faces apart and find the areas of each face. And once we do that, then we can add those areas up to get the area of the whole prism. Well, here's what the faces look like. We've got the biggest face, we've got what was on the left there, the front and the back, and then what was on the bottom. Let's put those dimensions in. The left face is 4 meters by 6 meters. The back and the front are each 4 by 3. They're triangles, right triangles. The biggest face is actually 5 meters by 6 meters. And the bottom is 3 meters by 6 meters. Well, let's see. We've got to find the areas of these faces. The area of the left face is 24 square meters because it's 4 meters times 6 meters. The area of the biggest face is 30 square meters because it's 5 meters times 6 meters. The area of the bottom is 18 square meters, 3 meters times 6 meters. And the area of the back is 6 square meters. It's half of 4 times 3 square meters because it's a triangle. And the same for the front. So now that we have the areas of each of the 5 faces, we add those areas up and we get the total surface area, which is 84 square meters. Next, we consider cylinders. A can is an example of a right cylinder. Its bases are its top and bottom, and its side is its label. To find the surface area of a right cylinder, we must first know how to find the area of its label. This is called its lateral area. Here's a cylinder of height h and radius r. We're going to unwrap the label and we see that the length of the label is actually the circumference of the circle. The circumference of a circle is pi times the diameter, or 2 pi times the radius. So that we can see that the label has a width of h and a length of 2 pi r, where r is the radius. So that gives us the lateral area, which is 2 pi r times h, or 2 pi rh. The surface area of the cylinder is the top plus the bottom plus the lateral area. While the area of the top and the area of the bottom is the area of a circle, which is given by pi r squared. So what we have is pi r squared plus 2 pi rh, and so we can use that formula to get the total area of a cylinder. Let's work an example. A right circular cylinder has a radius of 4 inches and a height of 10 inches. Find its surface area. Here's a picture of the cylinder. In order to find the total surface area, we need first to find the lateral surface area, the area of the label. And the label is a rectangle. The length of that rectangle is the circumference of the circle. And the width of the rectangle, of course, is the height of the cylinder. So the lateral area, being the area of that label, is 10 times the circumference. Well, the circumference is 2 pi r, so that's 2 pi times 4. And so we have 10 times 2 times 3.14 times 4. In the parentheses there, that multiplies to 25.12. I used a calculator. And that gives us 251.2. So it's 251.2 square inches for the lateral area. Now, as far as the top and the bottom are concerned, they are circles, and the area of a circle is pi r squared. Top is pi r squared. That gives us 3.14 times 4 squared. Well, again, I use a calculator, and I get 3.14 times 16. 4 squared is 16. That's 50.24. And the bottom is the same as the top, so that's also 50.24. The units here are square inches, because the measurements were in inches. And so the surface area is the top plus the bottom plus the lateral area. And we have 50.24 square inches plus 52.24 square inches plus 251.2 square inches. And again, I used a calculator, and I got 351.68 square inches. Here's another example. A base of the right solid 10 feet high is shown. Find the surface area of that solid. Dimensions are in feet. Well, we have to find the lateral area and the area of the top and the bottom. And the base is one of those, the top or the bottom. It's shown here. It seems to consist of a rectangle and a semicircle. Let's see, the rectangle is 5 by 6, so its area is 6 times 5, which is 30 square feet. And the semicircle, let's see, the radius is 3. The circle, the area is pi r squared, which would be pi times 3 squared. So that's pi times 3 squared divided by 2, because it's a semicircle, half a circle. And I used my calculator and got 14.13 square feet. So if we add those using a calculator, we get 44.13 square feet for the area of the top or the area of the bottom. Now, as for the lateral area, let's see. If we look at the base there and we stretch something around the base, we have to stretch a 10-foot high strip of paper around the base. We're going to get something like this. You see, I started at the 5 at the top part of the base, and then the 6 going down on the left side, and then another 5 going across to the right, and then we have the half of the circumference of that circle. So the circumference of a circle is 2 pi r, and that would be 2 pi times 3, which would be 6 pi, but this is a semicircle. So we got half of that, which is 3 pi. So that's the length of the rightmost rectangle that we have when we unfold the label of this figure. So we can figure the area of the side. We could add up all the bottom parts and multiply by 10, or we could take each rectangle separately, which I did here. We've got 5 times 10 is 50 square feet for the first one, 60 square feet for the second one, that's 6 times 10. 50 square feet for the third one, and then 3 pi times 10 is 30 pi square feet for the final rectangular piece of the side. So the lateral area is all of that added up, and we have to put 3.14 for pi. 50 plus 60 plus 50 is the 160 there. And then I used a calculator again and got 254.2 square feet for the lateral area. Okay, now we can put this together. The surface area of this figure is the area of its top plus the area of its bottom plus the lateral area, which gives us the 44.13 added twice there, plus the 254.2 square feet. And that comes out to 342.46 square feet. This is the end of Lesson 15. Your assignment, problem set 15, on pages 70 through 72 of your book.